Thank you, viewers. This is Mr. Dingo here, and I want us to continue with the equations of straight lines that we did last time. Now, before I begin, I want to ask you to please support us by subscribing to our channel so that we can learn together. Now, today we want to finish this area of length of a straight line. And when we are determining the length of a straight line, we need to be able to reason on the basis of Pythagoras theorem. And if this is the straight line AB, where I want to say the coordinate of A is x1, y1, and the coordinate of B is x2, y2. That is those are the coordinates assuming. Now, if I try to be able to obtain something like a right angle triangle here, you realize that this is 90 degrees. Now, the distance here, we know that for a right angle triangle, the sum of the squares of the two shorter sides should give you the square of the longer side. So this side here, if this is our x, like we have said, this is our x1, this is our y1, this is our x2, this is our y2. So if I want to get the distance between the length from this point to this point, the horizontal line, I'll be able to take this distance here, which will be x2 minus x1. And the distance from here to here also will be y2 minus y1. That is what we have here. So if we have this length here, the shorter side we have, and the other shorter side also we have, then we can be able to get the length AB. The length AB here, let us represent to it as distance D. So distance D, the distance between A and B, D, is given by, we know that according to Pythagoras theorem, D squared should be this shorter side squared, which is x2 minus x1 squared, plus y2 minus y1 squared. That is what we have. Now, going forward to get D, we have to get the square root of both sides. So it means that D will be the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the formula for getting the distance of a straight line between any given points. Now that we have the formula for determining the length of a straight line, let us be able to look at example 1. And example 1 in this case is examples. So example 1 here we have, for example, N1, find the length of line between A 4, 3 and B 12, 9. So if you are asked to get the distance between the 2 points A and B, where A has coordinate 4, 3 and B has coordinate 12, 9, the first thing we do, we remember the formula where we said the distance D is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. That is our formula, where we can say that this one here is our x1, this is our y1, this is x2, this is y2. So it means that if I'm getting D, I will say D equals to the square root of x2 is 12, so 12 minus x1, which is 4 squared, plus y2 is 9 minus y1 is 3, also squared. So d here will be the square root of, we know that 12 minus 4 is 8, so that is 8 squared, plus 9 minus 3 is 6, that is 6 squared. So d here will be the square root of 8 squared is 64, plus 6 squared is 36. We know that d in this case will be 100. So that is 64 plus 36 100. So the square root of 100 here will give us 10. So we can say that the length now here equals to 10 units, where these units could be centimeters based on the value, the type of units that you have. So viewers, you see how it is very simple to get the length of a line between any two given points. Let's look at example 2. Let's look at example 2. Example 2 is find the length of a line between P, and P is -1, -4, and Q, where Q is 3, 2. Express your answer. Express your answer in SAD form. Express your answer in SAD form. So let's not get worried with SAD form. We have done SADs before, so it's going to be easier for us to understand what we are doing next. So one thing we do, D here, the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So this will be square is up there, sorry. So now this one, we can say the square root here will be x2 is 3, so 3 minus -1 squared, plus we have 2 minus -4 also squared here. So we know that this is 3 minus -1, which is going to be 4. So we are going to have 4 squared, plus 2 minus -4 is 6. So also 6 squared. We know everything is under square root. So here we are going to get 4 squared is 16, plus 6 squared is 36. So when we have that one, 16 plus 36, 36 plus 16, that will give us 2, then here 5. So we have 52, the square root of 52. But we know that we are told to give in the SAD form, so we have to simplify this one. And in this case, we know that 52 is the same as 13, 4 times 13. So 4 times 13, the square root of 4 here is 2. So we're going to say the length is 2 SAD 13 units. So viewers, this is what we have, and those two examples are enough. This was supposed to be example 2 that we are doing. So with that one, the length of a line is very simple to get if you follow the formula. Sometimes students forget to use this one as plus. The minus are between the two coordinates of x and the two coordinates of y. Remember, whether you get the difference here as negative and the difference there as negative, it doesn't matter, because the square sign here will change those numbers into all numbers, positive numbers. Remember also that we have said x2 minus x1. You can also say x1 minus x2. It doesn't matter how the order in which you arrange them. The answer you are going to get is still the same, because we are basically looking at the difference. Whether that difference is negative or positive, you have said this square number will take care of it. Now, let's move to the next thing, which is getting the midpoint of a line. Assuming you have a line starting from point A and point B, it must be a finite line, a line with boundaries. An infinite line, usually without points, you cannot be able to determine the midpoint because you don't know between which points are you looking for the midpoint. But a finite line is a line segment that actually we have parts, at least the starting point and the end point, meaning boundaries. For in this case, the starting point is A and B. So we have a line between point A and point B. Now, if you want to get the center, the coordinates of the center of this kind of line, the first thing we have to do is to be able to simply halve. For example, what we are going to do in this case, if we have, we want to get M in this particular case, then the coordinates of M, midpoint M, should be x1 plus x2 over 2 plus, not plus but comma because we're dealing with a coordinate, then y1 plus y2. This is what a midpoint should give us. So coordinate M in this particular case should be x1 plus x2 over 2, y1 plus y2, everything divided by 2. So that is the method we need to use. Now, if you have a question here, we are told to find let's say the question example. Example here is number 1, the line segment AB of the center of the circle O. Now, what we are told in this particular case here is that we have a circle, and this circle here, and believe me, this is like a application kind of question, which is not just telling you to get the midpoint directly, but it's telling you that the coordinate of a line segment, which is actually, the line segment is actually the diameter of a circle, assuming that's the line segment A and B. And what we are told here is that A has coordinate -3, 8, and B has coordinate 5, 4. Now we are asked to get the center of this circle, which is O. And the center of the circle, we know that the center of a circle divides the diameter into 2 equal parts, meaning the center, O in this particular case here, should be our midpoint M. So what we are going to do in this case to get M, like we said, M is given by the formula x1 plus x2 over 2, comma, y1 plus y2 over 2. Now remember that, like I said, you can put x1 to be any number. Don't think that every time there x1 must be a particular number. You can say x1, y1, x2, y2, or x1, y1, and x1, x2, y2. That choice is all up to you. Now the midpoint in this particular case here, if I assume that my x1 is here, y1 is here, this is x2, y2 are there, what I'm going to do is that x1 is -3, so plus that one, which is 5 over 2, comma, then y2 is 4, y1 is 8, plus y2 is 4 over 2. This one M here will be, and in this case, -3 plus 5 is 2. 2 divided by 2 is 1, comma, 8 plus 4 is 12. 12 divided by 2 is 6. So our center O of this circle is 1, 6. This is the coordinate of the center of this particular circle. Now, sometimes they'll ask you a direct question that get the midpoint between this coordinate and that coordinate. That's very direct. But in this case, we are asked to get the center of a circle, which is actually the center of a diameter. Now, I want to move to what we call perpendicular bisectors of lines. Now, if you have a straight line, assuming this is the straight line that we have, this is the Cartesian plane. If that's the straight line that I have, and this is A, B. Now, to bisect a line, if we perpendicular bisector of a line usually divides a line into 2 equal parts. So if I have to define a perpendicular bisector of this line, for example, it must be meeting line AB at 90 degrees. This is the perpendicular bisector. This is the bisector of line A, B. And because it's perpendicular bisector, we know that this perpendicular bisector must be passing this line AB at its center, meaning at its midpoint. So it means the point where they're intersecting here is actually point M. Now, if you are told to get the equation of the perpendicular bisector of line AB, we have to put into place a number of concepts. One of these concepts should be getting midpoint. Is very important. The other important concept is what we learned before, which is determining the equation of perpendicular lines. We know that if this bisector is perpendicular to line AB, it means that the product of their gradients will be -1. So the first thing we are going to do in this case, if we have an example like in this case, we have a line segment, and this line segment AB is actually a diameter like they have said, or let me write another example here and see. So if you have example in our case here, I want to take the information we have down here. So a line segment, say a line segment. Now in this case here, we first of all have to be able to determine the gradient of line AB and also the midpoint of line AB, because those are key things. The gradient of line AB will help us to get the gradient of the bisector, because we know the product of their gradients should give us -1. And also, now that we have the gradient, we must get a point where the bisector is passing, and that point can only be the midpoint of line AB. So let me start by getting the midpoint M, line midpoint of AB, which we have said is x1 plus x2 over 2, y1 plus y2 all over 2. So M in this case will be, like we have said, -3 plus 5 over 2, comma 8 plus 4 over 2. M will be -3 plus 5 is 2, divided by 2 is 1, 12 over 2 is 6. So we have the midpoint, we put it aside. Then the next thing, we want to get the gradient of AB. So gradient of line AB, which I'm saying small m, the gradient of AB, let me use AB there, will be change in y over change in x, change in y over change in x, which is also basically y2 minus y1 divided by x2 over x1. So if we continue with that, assuming this is my x, y, x2, y2, x1, y1. So I'll say 5, 4 minus 8 divided by 5 minus 5 minus -3. This is going to be 4 or -4 over 8. So if you have that, that one will give us -1/2. So the gradient is -1/2. That's the gradient of line AB. Now if the gradient of line AB, I know the way I've drawn it doesn't show negative, but it was just a sketch. The way I've drawn this line shows a positive gradient, but it's just a sketch, so I hope you understand that particular point. Now if we want to get M1 times M2 will give us -1. So it means that if I take the gradient of AB and the gradient of the bisector, I should get -1, but I have the gradient of AB here. So gradient of AB here, I'll say, let him say is -1/2 times the gradient of the bisector should get -1. For me to get M2, I will say is -1 times -2 over 1. So M2 in this case will be +2. So the gradient of the bisector is +2. And like I said, the bisector, the way I've sketched it, shows it has a negative gradient, but it was a sketch, so we understand what we are doing. Now that I have the gradient and I have the coordinate where that bisector is passing, I can get the equation by saying now y minus 6 over x minus 1 should give me 2. If I multiply that, I'll get y minus 6 will be equals to, this will be 2 into x minus 1. So y minus 6 equals to 2x minus 2, and y will be 2x minus 2 plus 6. So the equation of the line is y equals to 2x plus 4. This is now the equation of the perpendicular bisector of this particular line AB. So you realize that these ideas keep on building from one to another, and you have to put them together for you to be able to solve a problem. Let us try to look at example 2. Now example 2 here says the line segment AB is the diameter of a circle with center C, where A and B are -1, 4, and 5, 2 respectively. The line L passes through C and is perpendicular to AB. Find L. Now the first thing I want to do is to get C, which is the midpoint, and like I said, the midpoint of a line is x1 plus x2, and x1 here -1 and 5. So I'll say -1 plus 5 over 2. Then y1 plus y2, which is 4 plus 2 over 2. So this will give me -1 plus 5 is 4 over 2 is 2, and 6 over 2 is 3. So we have the midpoint or the point C, which is the center of this circle. Then we move to gradient M. Let me say M1 is the gradient of line A, B. So here we'll say y2 minus y1 over x2 minus x1. So I'll say y2 is 2 minus y1 is 4 divided by x2 is 5 minus x1 is -1. So I'll say this one is -2 all over 6, which can be -1/3. So if it is -1/3, and we know that M1, let's now get M2. M1, M2, where M1 is the gradient of AB, M2 is the gradient of line L, which is the perpendicular bisector of line AB. This will give me -1. But M1 is here, which is -1/3, so -1/3 here, times M2 will be -1. So for me to get M2 here, I will say, if I multiply both sides by reciprocal of this, I'll say -1 times -3 over 1. So M2, which is the gradient of the perpendicular bisector, is 3. So if the gradient is 3, so it means that I have gradient which is M is 3. I have the coordinate where the bisector is passing, 2, 3. And finally I have x, y. So the equation will be y minus 3 over x minus 2 to give me 3 over 1. Multiply here, y minus 3 equals to 3x minus 6. So this will be y equals to 3x minus 6 plus 3. Y here will be 3x minus 3. This is the equation of line L, which is the perpendicular bisector of line AB. Now viewers, as you can see, we have dealt with, in this lesson, we have been able to cover how to determine the distance or the length between 2 points in a straight line. We have also been able to determine the midpoint, and we have also used that midpoint that we have gotten to move forward to determine what we call equation of a perpendicular bisector of a straight line. Now that will mark the end of our lesson today. And please viewers, if you liked our video, please share with your friends, your family members, and also please support us by subscribing to our channel. Thank you very much, and see you next time. Bye bye.